So yesterday we started learning about the slope formula. Slope formula is this formula where you subtract your y values, and then in the denominator you subtract your x values, and then if you need to, you simplify. So here's an example of it, and it's a different way of finding the slope where we don't use rise over run to find the slope. And it's useful if we don't have graphs or if the numbers are too extreme and it's not a good idea to graph them. And today's assignment on Delta Math, we're going to practice both. We're going to practice finding slope with rise over run, and then we're going to practice finding slope using the slope formula, and also with tables of information. Okay, so we're going to continue on the back here. So let's begin. So we have these two tables, and they're telling us the two tables have a linear relationship. That means if I plot the points and connect them, it would form a straight line. Okay? So we have the directions. It says choose two pairs from the table and use the slope formula to find the rate of change. I'm going to underline that. So once they tell you that the table has a linear relationship, any two pairs of points along with the slope formula will give us the slope. So let's choose some pairs. We have x and y values that go together. So I don't know about you, but anytime I see a 0, that's usually a good point to pick. Just makes doing the math easier. What's another practical point I want to pick? Do I want 1 and 5.5, 2 and 6, or 3 and 6.5? 3 and 6. If you can avoid decimals, definitely do that. So here's our points. We have 0, 5.0, 5, and then we have 2, 6. Okay. So at this point, they want us to set up the formula right here. So let's do that. And so this is from yesterday. What we do if you were absent is we create a fraction bar and then subtraction, and then we plot in our points or plug in our points. Do you remember how we did that? You take the second one, 2, 6, and imagine rotating it 90 degrees counterclockwise so that 6 is on top and 2 is on the bottom. They go here, 6 and 2. And then you do the same thing to your first ordered pair. Okay? So that would be 5 on top, 0 on the bottom. And then we subtract the numerator, denominator, and see if we have to simplify. So let's do that. So first we have 6 minus 5. That's going to be 1. And then 2 minus 0, that's 2. So that's our answer. 1/2, 1 over 2. So now we can even imagine if you graph the line and you're on the line, you go 1 space up, 2 spaces to the right, and you find yourself back on the line. Okay? That's the slope of this line. Any questions? Okay. Let's practice that with the second one. Let's pick a couple of points. I'm going to pick 3 and 15. Which other one should I pick? How about 11 and 15? Okay. So let's see what that gives us. Set up your slope formula. Let's plug in those numbers. So what do we have? 3 and 15 and 11 and 15. So it looks like 15 goes on top for either. What would be the bottom, the x value? 11. That's good. So that means this is 15 and 3. And let's do some subtraction. 15 minus 15, 0. 11 minus 3, 8. Which one is it if the zero's in the numerator? Zero or undefined? Zero. So this line has a zero slope. So it's one of those horizontal lines, perfectly horizontal. Yeah, if it would have been on the bottom, remembering from yesterday, that would be undefined. Okay. Excuse me. Number 4 says a web designer charges customers an initial consultation fee plus an hourly rate. The table shows the linear relationship between X and Y, and X is the number of hours. So this is X. And Y is the total cost. So you can see for 2 hours, he charges, the total cost is 205. 5 hours, it's 400, etc. So the first thing they want us to do is find the rate of change. So let's pick some numbers. I like dealing with the smaller numbers. So let's pick 2 and 205, and then 5 and 400. Okay. So those are our X and Y values. Okay. We have the first ordered pair is 2, 205. The second one is 5 and 400. Okay. So let's use the slope formula. You remember we use the letter M for the slope? Okay. So which number would go here in this location? Yeah, let's do 400. I prefer using the second ordered pair for x2, y2. That means 5 goes down here. So what are we going to put above and below here? $205 and then 2. So what does that give us? 400 take away 205, that's 195. And then we have 5 take away 2 is 3. So now we have to divide. Let's see how many times 3 goes into 195. 6 times, and 3 into 15 is 5. This is going to be 65. If you divide 195 by 3, you get 65. Okay? So the rate of change is 65 over 1. So I have a question for you, though. In the numerator, what are we measuring, X or Y? Y. What does Y represent? Total cost. So that's in dollars. What are we measuring with X? Hours, and that's in the denominator. So it's $65 for every 1 hour. That's what he's charging. So to get this consultation with this web designer, he'll charge you an initial fee, maybe $100 or something, plus $65 per hour. Okay. So let's see if we can't answer that part B. What does the rate of change represent in the context of the situation? What does $65 per hour represent? What are you paying the $65 for? Yeah, you're paying it every hour for the web designer. So maybe we could say how much the web designer charges per hour. Is that a lot or a little? What do you think? Is that a lot of money if you're charging somebody $65 an hour? Yeah. Maybe plumbers. Nowadays, whenever people charge you money, it's not cheap per hour. And we once you become an adult, you're going to be there at some point in time. Whether it's a plumber or maybe for your car, all kinds of stuff. All right. Ready for number 5? This one deals with the post office. It calculates shipping costs based on the weight of the item. In addition to a fee, the cost to ship a 2-pound item is $6.09. So I'm going to just highlight that. While the cost to ship a 7-pound item is $8.84. Okay? Make sure you're writing this down. Find the rate of change of the cost with respect to the weight. So X is the weight and Y is the charge. So again, this is going to be dollars per pound, it looks like. And we already have 2 ordered pairs here. Let's write them down. One of the ordered pairs is 2 pounds costs you $6.09. What's the other ordered pair? 7 pounds. And that's going to cost you $8.84. $8.84. Okay. So let's set up the formula to get the rate of change. Notice how sometimes they call it slope and sometimes they call it rate of change. Remember we said that they mean the same thing. Okay, so let's set this up. $8.84 over 7. $6.09 over 2. And if we subtract this, what do we get? $2.75. And then 7 minus 2 is 5. So this tells us it's $2.75 for 5 pounds. Let's get the cost per pound. Let's divide 275 by 5. Okay. 5 into 27 is 5. Then you get 25, so it's 55 cents. And just did a quick division. So it's 55 cents for every 1 pound. Thank you. Okay. So 55 cents per pound. So you'd be surprised how useful this stuff is. You know, if we didn't study slope and rate of change, you may think I'm exaggerating, but it's true. If we didn't study slope way back whenever they started studying it, we wouldn't have this modern world we live in. Computers, airplanes, rocket ships, everything. I'll tell you in the end why. Okay. We have Jude and Yin. Each student chose 2 points on the graph line below and drew a right triangle. So it's rise over run. So this is what Jude did. This is what Yin did. And it says they found the slope. Use Jude's points to set up and simplify the slope formula. I think we'll just use rise over run. Whenever I see graphs, it's easier. So let's study the graph. And I like the way Jude did it because she picked this point to start with, and she's going down to this point. How many spaces did we go down? 2. So since we went down 2, that's -2. And then it looks like she went 3 across. Do you see that? So what would the slope be in this case? Well, remember, it's rise over run. It's how much you go up or down versus how much you went across. So we went down 2. That would be -2. And we went to the right. That would be +3. So June found it to be -2/3. Okay. Let's try the next one. Use Yin's points to set up and simplify the slope. Again, we'll use rise over run. So this is the starting point for Yin. How many spaces did she go up? Count the spaces with me, please. 1, 2, 3, 4, 5, 6. So she went up 6. Okay? And then she went to the left. How many spaces to the left did she go? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. But since she went to the left, I can't say it's +9. It's -9. Remember, up is positive, down is negative for the rise. Right is positive, left is negative for the run. So the rise over run here is -9/6. I guess I didn't get the memo about not going out. Okay. I got a different slope, didn't I? Or did I? Is that going to be a different slope? Can I simplify it? Is there something that goes into 6 and 9? 3. And when I do that, look what I get. -9 divided by 3 is -2. Oops. Oh, yeah. Hold on. You know what I did wrong? I put my numbers in the wrong order. I do the rise over the run. Here I did the run over the rise. Let's fix that. I apologize. We are going to have to reduce it still, though. Okay. So the rise was 6. And the run was -9. Okay, that's better. And we could still divide by 3. Okay. So now, what do we get if we do that? 2 over -3. So basically, it's the same number. It's still -2/3. All right. How are the two triangles related to one another? It's something we're going to cover later, but these two triangles are proportional. So triangles are proportional. And we'll learn more about proportional triangles later when we do some geometry. More importantly, I want us to answer this last question, question D. What can we assume about the slope between any 2 points on the same line? So if we're on the same line, what's the slope going to be? Is it going to be different or the same? We got negative 2/3 here, and when we simplify, we got negative 2/3 here. So can we assume it'll be the same or different? The same. So let's just say two slopes from the same line are equal. Any two slopes from the same line are equal. Okay. So go ahead and write that down. So now, how many of you have ever heard of a class, or maybe you know someone, a family member, someone that's taken or is currently taking a class called calculus? Anybody? Calculus sound familiar? A few of you. Well, it's a class that you can take in high school or college. It's usually in high school. It's kind of like the end of the line. That's as far as you'll go unless you want to get into statistics instead. But the whole idea of calculus has to do with slope, but not the slope of lines, because the slope of lines is kind of boring, believe it or not. It's the same all the time. No matter where you look at the line, it's the same. But if you have curves that you graph, the slope is going to be different. Okay? So I'm going to show you what I mean. So look at this here. This here in red is a curve. And it's usually when you're graphing something like x to the third power, it's going to look like this. Calculus is all about, if you pick a point on that line, find the slope. And so here's the line that would give you the slope for this point. Here's the line that would give you the slope for this point. If I pick a different point, it has to be what's known as tangent. So it's only going to touch at that one spot. So do you see the slope is constantly changing? The math involved to learn how to find these slopes is calculus. And that's basically the type of math that gives us the modern world that we have today. Because that's the math that allowed us to create microchips, figure out how planets go around the Earth or the sun. Got to work on my science. How to figure out the math involved for falling bodies. All kinds of important things that really gives us the modern world that we enjoy today. All right, guys. So today's assignment is on delta, and it's practicing rise over run on graphs and finding the slope using the slope formula.